Alright, so today we'll be talking about how to draw a Lewis structure and determining what type of bonds a molecule has. So the very first step in calculating a Lewis structure is to count how many valence electrons are in the molecule, the total number of valence electrons. Then what you want to do is find the number of electrons per atom so that each atom satisfies the octet rule, which means 8 electrons are on the outer shell of the atom, or in some cases 2 electrons for, let's say, hydrogen or helium. Now, the third step is to determine how the bonds are going to work. So typically, you want to find what the central atom is, and in our case, the central atom is going to be the least electronegative atom. So the way to find electronegativity is, in a periodic table, as a general rule, electronegativity increases when you go from left to right, and it decreases when you go from top to bottom. So the most electronegative element is fluorine, and the least electronegative element is here. So the least electronegative element is going to be the central atom. Then what you want to do is you want to draw a skeleton structure. So for the skeleton structure, you want to draw the central atom, so here, and then connect it to other atoms, and you can have a maximum of 4 single bonds to other atoms, and you want to keep doing this until you satisfy the octet rule for each atom, and you can change the bonds to make it a double bond or triple bond. And you want to do this until each atom satisfies the octet rule and the total number of valence electrons add up to what you found in step 1. So step 1 and step 2 need to be satisfied in step 4. And after you do that, you want to place the electrons in lone pairs around the other atoms if they don't fill up the octet rule. So, for example, if I had H2O and I connected oxygen to H, and then, so we know that H satisfies the octet rule, then you want to add 2 sets of electrons here so that O would satisfy the octet rule too. So that's the last step, to fill the central atom with lone pairs. Now let's do an example. Let's say we want to find the type of bonds in the molecule tellurium dioxide, TeO2. So the first step here is to calculate the number of valence electrons. So oxygen has 6, and we have 2 oxygens, and tellurium has 6. So we add that, we get 18 valence electrons. Now, we know that Te is less electronegative, so Te would be the central atom. And then here, for each atom, we need 2 more electrons. 2 electrons to satisfy the octet rule, since each has 6 valence electrons, and 8 valence electrons would satisfy the octet rule. So now, when we're drawing the skeleton structure, we had Te here, and then we have oxygen here and here. So let's try with a single bond first. If I do a single bond here, and there, that's 4, so this satisfies the octet rule, Te. Then oxygen would have 3 sets here, 3 sets here, 3 sets here. Now, as you may notice, the total number of electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, is 2 more than the actual number we calculated here in 18. So we have to change some stuff up. So what we can do is we can have a double bond here. So now, if we have a double bond with this oxygen, we take out this pair of electrons, we can see that the total number of electrons is 2, 4, 6, 8, 10, 12, 14, 16, 18. 18, which satisfies the total number of valence electrons, and each atom satisfies the octet rule. As you can see, oxygen has 8 electrons, tellurium has 8 electrons, and this oxygen has 8 electrons. So in our answer, it would be one double bond and one single bond.